Hi, my name is Ben Sunderland, Sales Engineer at Datadog, and today we're going to go through a demonstration of Kubernetes monitoring at scale. So we start off the demonstration with the overview page, and what we've tried to do is design the most important signals from your Kubernetes cluster in terms of monitoring. So at the start, you can see the count, right? So how many resources that we've got, how many clusters, namespaces, nodes, deployments, pods, containers, etc. And I can drill into all of those to find more information. What auto scaling operations have occurred and the associated idle cost, and you can see that at a deployment and cluster level. The next one is troubleshooting patterns. So this really helps jumpstart your observability into Kubernetes by examining the health of your pods, your replicas, containers based on restarts, and your nodes and volumes. So these are the 5 top troubleshooting patterns that most people sort of care about and want to jump into off the bat. Resource utilization, so provisioned under and over provisioned workloads in terms of CPU and memory. Some dashboards, and then some recommended monitors. And these are basically the top 10 best practice monitoring alerts that you can set up. And the best thing about these is you can single click for really fast return on investment and really jumpstart your Kubernetes monitoring very, very quickly and easily. The next view is to look at all of the pods, right? So here I've got my Kubernetes navigator. This will show me all of the different namespaces and the types, the object types around my clusters. And in this case, you can see I've got 4,000 pods. And they're all in a big list, which I can paginate through, but more likely I'm going to want to filter based on status. So if I want to look at crash loop back off, I can just single click and that will give me all of the pods across all clusters in this case that have that crash loop back off status. And I can click on multi-select a number of problematic situations and that will give me that list. Or I can group, and that will group all of those pods based on those problematic symptoms that I've selected. That's really useful to quickly at a glance understand the health of my clusters. Looking down the facets, we also have the phase, ready state, the actual cluster, so I can filter based on an individual cluster, and the numbers on the right give me, show me how many pods we actually match. So I can see the cluster with the highest number is this one here. Further down, I can sort by namespace and deployment. So maybe I want to group by deployment, and that will immediately give me all of my deployments. Also, and if I want to get rid of the status, I can quickly sort by all of my deployments, and I've got 117 different groups there. I might want to sort that by in your clusters. The next is about visibility. So as you scale your Kubernetes environment, having detailed visibility is really going to help understand the macro health of your environment. So in this case, we're looking at all of these nodes are pods. So we've got pods selected, and maybe I want to filter that based on cluster name. So I can do that with a single click that will render, and then maybe subdivide that by deployment. And single click, I can drill in, and that will give me a nice breakdown based on cluster and then deployment. Or I might want to collapse and just go deployment across all my hyperscalers, and that will give me a view there. And I can see the celery worker has some memory pressure that we might want to investigate. So if we switch back to the pod view and we look at the celery worker, you can see that there are some problematic pods. So let's say I go into one of those, for example. The troubleshooter helps me at a glance drill into the actual health of that particular pod. And you can see this example here, which is an individual pod. You can see the name, all of the tags and so on. In this case, there's been 560 restarts in the previous period, and most of those have been due to out of memory. So we might want to look at that. And you can see the memory requests provided as part of this troubleshooting feature, which is going to guide the SRE into the root cause of that problem. Let's say I want to just explore a little bit further. So let's say there is a .NET service. So I'm just going to go into one of these auth.NET pods just to examine the health a little bit further. So the first thing I get is the YAML view. And this is a color-coded, automatically displayed view of the manifest. And I've got the map down on the right-hand side. It lets me to jump to specific areas pod and just gives me a really nice way of navigating without having to shell into an environment to get to that and having to remember all of the commands and so on and so forth. I can also compare that to previous versions. So that gives me a visual way of comparing two different versions of that file. So if I was to change the time frame a little bit, you can see it's color coded where those manifests are different. And often we see that the problems in pods in Kubernetes can be related to errant changes in the configuration, and this is going to highlight that very quickly. So it's just a really useful feature to have. The next is the related resources. This is a map that you can interactively click through. Entity type, so I can see the cluster, namespace, deployment, node, pod, and container. So I've got that whole object hierarchy laid out for me, and I can just drill into and select the container, and that will take me directly to that particular container. So I can navigate through that map to really understand where this pod fits into the scheme of things. That are leveraging spans that are coming out of this particular pod. You can see this is GKE in this case, and I can drill into any one of these potential traces. You can see there's a 500 there. I can just drill into that, and that will take me directly to the trace view, and you can see how that particular pod is being used. And in this case, there's some SQL exception that we've jumped into, and I can view the stat trace of that particular issue right there if I want to drill into that a bit further. Coming back to Kubernetes though, it goes beyond that. So we've also got profiling. So let's say I'm the developer of this particular service, which is the .auth service in .NET. Now I can see the profiling. So that's the CPU and memory footprint of every single function within that particular pod. Also, I've got the metrics. So this is the golden signals and also the CPU memory and the resource utilization. We've also got what processes are running on that particular pod. So I can see the .NET. Obviously, you would expect that, but there's also some other executables or processes that are running. So I can drill into that without having to shell in. I can do all of this from the same UI. Network, this will show me the volume of network traffic emanating from and going into this particular pod, and I can see all of the metrics such as latency, retransmits, and jitter across those particular services. Any events coming in and out, and suggested monitors. So basically, Datadog is suggesting monitors that relate to events that it's seen on this particular pod. And I can single click to enable those, which is really going to fast track setting up observability on my clusters. Okay, so that's really a view of not just the pods, but where that pod fits in the lifecycle, and then all of the information and observability collected in context, which is really going to help in terms of trying to troubleshoot. You might also notice at the top we have Watchdog, and Watchdog is the AI service of Datadog, and that's going to come in and it's going to consume or ingest all of the telemetry. So that's to say metrics, logs, and traces and events, and it's going to look for outliers and surface those. So you can see things like unready pods, restarting containers, and unavailable replicas and so on and so forth. And I can drill into any of those and it will give me like a story and give me the relevant dates of when those issues happened. And it will also give me relevant monitors that you can turn on that will help catch similar events in the future, which is really going to fast track your path to observability. The next thing I wanted to look at was how we visualize the network map. So the network map uses eBPF to capture network traffic going in and out of the services that we've instrumented. But from a Kubernetes standpoint, I might want to look at the cluster. So I can look at traffic going between cluster. And so now I've got this visual that shows how these clusters are talking to each other. And it might be more useful to look at deployment actually and see how deployment are actually communicating with each other. And all of these circles reflect how much data is flowing in and out of these deployments. And you can hover the mouse over and it will give you the pop-out card and it will show you things like TCP transmits, jitter, latency, and so on and so forth. So a really good way to supplement the Kubernetes view using the network map. The next thing I wanted to go through is to look at the auto-scaling. The auto-scaling is part of Kubernetes. We can just drill into that at the top. And that's going to sort by CPU idle across all of my clusters. And then if I want to drill into the cluster with the most amount of idle, then I can sort the deployments, that's to say the workloads running on those clusters, and it will let me drill into each deployment based on idle. So you can see the auth.net service is what we were looking at before. Maybe I want to optimize how the resources are set up, and you can see the average cost per pod. It's broken that down over the month, and then the optimized cost per pod after changes, and then the estimated savings. So you can see that at a glance. We can look at that average per pod, and we can also look at the total across all pods. So the total here is 157. Obviously, there's a saving after the optimization, which is basically reduced the memory and the CPU provided. And then the estimated savings over the course of a month is around about $100 for that particular deployment. And of course, there's lots of deployments there. So really useful to have that available. The other thing that I wanted to show, if we go back to the Explorer view, we now have the container images view, and that allows me to look at all of the containers and the images that are leveraged by those containers. And you can see the vulnerabilities are scored, right, for each image. So if I drill into this one, for example, I can see that there are 9 high vulnerabilities. There's this storefront one has one critical vulnerability, and we can drill into these to find out more. This is the vulnerability that's deemed critical. Is stack buffer overflow, and I can drill into that, and it's got all of the detail around the severity breakdown, which is a combination of the base CVS score plus some Datadog analysis over the top. It's also got the window of exposure. So this has been around for the last 11 months, and when it was first found, and how long that's been running for, and more information around that. I've also got jump points, so I've got the timeline of when that first was discovered, and then all of the references. If we want to drill into the CVE, for example, that's all available. And that's about it from the demo. Hopefully you found that interesting. If you'd like to have a more detailed demonstration, please contact your Datadog rep, and we'd be happy to set up a further demonstration.